Hi class, Professor Dave here. Welcome back. Today we're going to do probability with counting principles. So let's get started. So we'll do these 5 things. Okay, example 1. Say we forgot our PIN code to our iPhone. There are 10 digits for each spot. What's the probability that we get it on the first try? Well, the probability of the event is just equal to the top is the number of ways our event can happen, which is 1, divided by the total number of equally likely outcomes. How many is that? Well, we have 4 spots. 1, 2. And we can put the digits 0 through 9 in each spot. So for the first spot, we have 10 choices. And then for each 10 of those choices, we have 10 for the next, and 10 for the next, and 10 for the next. And that's equal to 100,000, 10,000. So we have 1 in 10,000 chance of getting it on the first try. And that's equal to, move my decimal place over, so 0.0001. Okay. Say we have 10 attempts before the phone is completely scrambled. What's the probability that we get it before it's scrambled? Well, our probability of the event is the same idea, which is just equal to, now we have 10 chances of our 10,000, which is the same as the last probability multiplied by 10. So we have 0.001, or 1 over 1,000 chance. Okay, but say our PIN is 4 letters versus digits. Now what's the probability? Well, similarly, probability of our event is equal to the number of ways the event can happen, which is over 1. And how many, 1 on top, and how many ways on the bottom? Well, again, there's four places, but now each time has 26 ways of doing it. So it's 26 to the 4th, and that is equal to 1 over 456,976, which is equal to 2.19 times 10 to the minus 6, which is equal to 0.5034529,219. Okay, so in general, the counting rule, if we have n ways for the first spot and n ways in the second spot, then the total number of ways is just m times n, or n times m. Okay, now for factorials. Say there are 5 people in the room with last names starting with letters A, B, C, D, and E. If these 5 are randomly leave the room, what's the probability that they leave in the order, in the reverse order? E, D, C, B, A. Okay, well, the probability of that event, again, is just equal to the number of ways the event can happen, which is 1 way, out of the total number of possible outcomes. Now, how many different ways can people leave? Well, there's 5 people, so there's 5 choices for the first person leaving, right? Then once that person leaves, there's 4 people left, so 4 for the next one, and then 3 for the third one, 2 for the second, and finally the last person leaves. So that's equal to what's called 5 factorial, which is 5 with an exclamation point. If we multiply that out, that's equal to 120. So 120, and that's equal to 0.00833. Okay. Now, if 10 people enter a room and leave completely randomly, what's the probability that they leave in the order that they arrived? Okay. Well, there's 10 people in 10 slots, right? So the first choice was 10 times 9 times 8 times ... down to times 2 times 1, which is 10 factorial, right? Which is a pretty large number. Okay, 10 factorial is equal to 362,880. So the probability of this event is just equal to 1 over this number. Which is equal to 2.76 times 10 to the minus 7th. So in general, if there's n spots, then there's n factorial different ways it can happen. So in general, if there's n spots, then there's n factorial ways it can happen. Okay, part 3, permutations. If 10 people on a race, including you, your best friend, and another friend, what's the probability that you take first place, your friend comes in second, and your other friend comes in third? Okay, well, as all probabilities are, it's just equal to the number of ways the event can happen divided by the total number of outcomes. Okay, now there's only one way that your event can happen. Okay, and how many on the bottom? Well, there's basically 3 choices, and there's 10 people for the first spot, but once one person is chosen to go into the winning circle, then there's 9 for second place, then there's 8 for third place, and that's how you do it. So it's just 10 times 9 times 8, and that number is 720. So 1 over 720 is equal to 0.00139. Now this is also equal to, right? That's also equal to times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 7 times 6 times 5 times 4 times 3 times 2 times 1, because all those cancel. So that can be written as 10 factorial over 7 factorial. This can also be written as 10 factorial over 10 minus 3, these 3 choices, right? 10, 9, 8, then the rest of them, 10 minus 3 factorial. And that is equal to R720. And that is this thing called permutations. 10 permutations, 3 spots. 10 permutations, 3. So let's bring our calculator into it. Let's find out how to calculate 10p3. So we type in 10, then we go to here, math, and then probability, and we have NPR, so we scroll down, hit enter. So 10, and then we put 3 here, we hit enter, and we get 720. In general, the question is, does order matter? And if it's yes, then we use permutation. That is if ABC is different from CBA. A came in first, C came in first here, so it's different, and it's a permutation. So the general formula is, if we have n people and we're choosing r of them, then we have r spots, and we have n factorial divided by n minus r factorial. Okay, let's see this in action. Say we're selecting a fours volleyball team consisting of a setter, a right hitter, a left hitter, and a back row player from a group of 20 players. What's the probability that you get the best team? The best for each position. Now, does order matter? Yes, because we need the best hitter, right-hand hitter, left-hand hitter, the best setter, and the best defensive player. So order matters. And so, let's calculate the probability of this. Probability of our event is just equal to, well, there's one way to get all the best teams out of how many? Well, we have 20 players, order matters, and we want 4. So that's going to be 20p4. And that's equal to, let's bring our calculator in. So we type in 20 math probability and 4, enter, and we get this number here. 116,280. So 116,280. And that's equal to 0.0000086. Okay. Now, perhaps the easiest way of getting that is you have 4 spots, right? There's 20 for this one, times 19 for this one, times 18 for this one, times 17 for this one. And you just multiply those out. It's probably even easier. If you do that, you get 116. But if you were choosing 10 of them, or 12 of them, or 14 of them out of 80, then you probably want to use the formula. But if it's a small number, you can just use these. Okay, example 3. Suppose there are 5 people with last names starting with A, B, C, D, E, and you're in a group of 3 with a chairperson, a record keeper, and a researcher. You're going to draw a random sample of 3. What's the probability that you get the group whose last name starts with A, B, C for the 3 positions respectively? Okay, so does order matter? Yes, it matters, right? You want A to be the chairperson, B to be the record keeper, and C to be the researcher. So order matters. So we have 5. It's 5 permutations. 3 is the number. But that's just equal to 5 times 4 times 3. So that's even easier. And that's equal to 60. So our probability of the event is just equal to 1 out of 60. which is equal to 0.0167. Okay. Now let's see those events. Since there's only 60 of them, we can take a look at them, and here they are. There's all 60 of them. You start with like ABC, then you go ABD, ABE, then you have to say ACD and ACE, then you have to go ADE, then you have to start with BCD, and then you can go BCE, and then BDE, and then CDE, right? There's 10 of those. But then you can permute 3 factorial is equal to 6 for each one of these, like ABC, you can have all the permutations of it, CBA, right? And same thing here, ACD, you're going to have AD, ADC, CAD, etc. So there's 10 distinct types, but then you have all the permutations for each type. So it's 10 times 6 or 60 of these. And there they are. Okay, part 4, combination. Suppose you have 5 people with the same thing as before, and you draw a random sample of 3. What's the probability that you get last name starting with ABC? But in this case, there's no order, right? You just want a group of 3 people, and it doesn't matter who came first, who came second, who came third. So in this case, it's combination. It's going to be equal to NCR. And NCR is going to be equal to, in this case, we have, it's going to be equal to NPR divided by R factorial. And in our case, we're going to have 3 spots. You can have 5 times 4 times 3. But then you got to divide out by all those that are the same. And so you divide out by those 3 spots. So you can divide out by 3 factorial. And so you get 3 factorial is 6. 6 over 60, which is 10 distinct things. So our probability for this event is just equal to 1 over 10 or 0.1. And when order doesn't matter, okay, then what we have is we have these same things, but all of these are the same team. And all of these are the same team, etc., etc. So all we have is this distinct number, which is 10 distinct numbers. Or we would take our NPR, we would take our 5P3, which is all these 60, and divide out by 3 factorial, all these different permutations for the same distinct object. So we divide by 6, and we get 10. And that's why it works. Okay, so in general, when order doesn't matter, then you use combination. That is, if ABC is not different from CBA, then use combination. And combination is just NPR divided by R factorial, which is this formula, therefore. Okay. When testing for current in a cable with 10 colored-coded wires, a technician uses a meter to test 3 wires at a time. Suppose there is one set of 3 that is a problem. What's the probability that he finds it on the first time? Okay, well, the probability of our event is just equal to one way he finds it on the first time, and how many different? Well, does order matter? No, it doesn't, right? He's just testing 3. It doesn't matter the order of those 3. They're just testing 3 at a time. So that would be combination, NCR. And for this case, we have 10 of them. we choose 3. And so that's equal to, let's bring in our calculator. So 10 math probability, and down here is NCR. And then we put 3, and we get 120. So over 120, and that is equal to 0.00833. If we have 5 basketball players from 20 are to be selected for a team at random, what's the probability that we pick the 5 tallest players? Does order matter? No. If you're on the team, you're on the team. So it's combination. Probability of the event is just equal to, there's one way to get the 5 tallest out of how many? Well, there's 20 combination 5. And that's equal to, well, we can look at it as 5. So 20 times 19 times 18 times 17 times 16. That's the permutations. Divided by 5 factorial, r factorial. 5 factorial is 120. This all comes down to, well, let's take out the calculator. We can do 20 math probability this way, 5. We get that one. Or we can say 20 times 19 times 18 times 17 times 16, and divide it by 5 factorial, you might remember, is 120. Either way, we get the same thing. Okay, so in review, the general counting rule, if there's n ways to do the first and m ways to do the second, then it's n times m. If you want to know how many ways to order n objects, that's just n factorial. And 5 factorial is that. Permutations, when order matters, ABC is different from CBA, we use NPR, which is n factorial divided by n minus r factorial. And combinations, when order doesn't matter, when ABC is not different from CBA, such as a team selected where you can intermix players, then it's NCR, which is just NPR divided by r factorial, which is equal to this one here. Okay, well, I hope this video was helpful and you enjoyed your learning. Cheers.